Okay, let's discuss this example. 2-point charges Q1 of positive 2 microcoulomb and Q2 of negative 6 microcoulomb are placed 4 meter and 5 meter from a point P, as shown in figure below. So first, calculate the electric potential at point P due to the charges. B, if there is another third charge of positive 3 microcoulomb that moves from infinity to point P, what would be the change in electric potential for this charge? And when the charge Q3 is at point P, calculate the electric potential energy for the system of charges. Okay, so this question combines the concept of electric potential, the change in electric potential, and also potential energy of a system. Okay, so let's solve one by one. Okay, for question part A, we want to find the electric potential at point P. Okay, as we know from the equation list, equation number 5, to calculate the potential, we can apply equation V equals to KQ over R. Okay, since in the system we have two charges, therefore we will have two potentials, which are V1 due to Q1. So multiply with 2 microcoulomb over with the distance between point charge and point P, which is 4 meter. So we will get the value for that is 4,500 volt. Okay, that is the unit for potential. And we'll do the same for charge number 2, where the value of the charge number 2 is negative 6, which needs to be included and divide by the distance, which is 5 meter. So we'll get the value of that is negative 10,800 volt. So since we want to find the potential at point P, and P has two charges, so the total at point P will be V1 plus V2. Okay, because it doesn't involve any direction, therefore we can simply total the two potentials up. Okay, so from the calculation, we will obtain the value of the potential at point P equivalent to negative 6,300 volt. Okay, so for part B, we want to find the change in potential energy due to a charge that is moved from infinity to point P. Okay, so first, if we apply equation number 6, we have change in potential energy delta U equals to Q delta V. So here we need to understand the meaning of delta V. Delta V is the potential difference, as in the difference between potential final to potential initial. So from the question, we can see that the charge is moved from infinity to point P. Therefore, infinity will act as the initial point and P will act as the final point. So for initial, since it is from infinity, so taking any charge divided by an infinite value, you will get 0 volt. Okay, so to obtain the change in potential energy, we substitute the charge that is moved from that infinity. Okay, multiply with V final, which is point P. Okay, so do the substitution and calculate to obtain the answer for change in potential energy. Okay, so we get negative 0.0189 joule. Lastly, okay, so now charge 3, which is 3 microcoulomb, is at point P that has been moved. So we want to find what is the U of the system. So for this question, we can use equation number 8. Okay, since there are now 3 charges in our system, so we can apply this equation to calculate the total potential energy for all the charges that are in our system. Okay, so I will not be substituting all the values. Instead, I will straight away write the answer that I obtained from the substitution. Okay, I believe all of you here can do your own substitution based on the values that we have from the question above, where Q1 is 2 microcoulomb, Q2 is negative 6 microcoulomb, and Q3 is 3 microcoulomb. Okay, so all the distances are as respectively. So do your substitution here. Keep in mind to include negative sign. Okay, so that's how I get all these values here. And finally, when we calculate our calculation here, we will get answer for our potential energy of the system. Okay, so you can go through once again to understand the solution. Alright, you guys, so let's try to solve this question now. So for this question, we have 2 points which are S and T that are located around a point charge of positive 5.4 nanocoulomb as shown in figure here. So calculate the electric potential difference between point S and point T, and also the work done to bring a charge of negative 1.5 nanocoulomb from point T to point S. So here there's a keyword of the initial and final position. Okay, so before we proceed with our calculation, right, we need to know what will be the distance between the point charge, positive 5.4 nanocoulomb, with point P. Okay, so we can apply concept theorem Pythagoras to find the hypotenuse of the triangle, and based on calculation, we will get 10 centimeter. Okay, so now let's solve part A. So to find the electric potential difference between point S and point T. So that means we need to have what is the potential at point S and what is the potential at point T. So keep in mind, each point charge will produce its own potential. Okay, so here I'm calculating the potential for point S. Okay, where the distance is 6 centimeter. Convert into meter. So we'll get 810 volt. Okay, and we will do the same for point T, where the charge is still the same. Point charge 5.4 nanocoulomb, and the distance for this point is 10 centimeter. Okay, so that gives us 486 volt. Okay, so the two values that we just calculated are the values of potential at each point. But to get the potential difference, okay, since the question used the word between, so it doesn't matter if you want to take Vs minus Vt or the other way around. However, question part B has specified that the motion of the test charge is from T, which will act as the initial, and point S which will act as the final. Therefore, to get the potential difference, I will use Vs minus Vt. Okay, as in V final minus V initial right away. Okay, so we will have 810 minus 486. So our potential difference will be equivalent to 324 volt. Okay, and then for part B, to calculate the work done. Okay, so actually if you look at equation number 6, where we have delta U equals to Q delta V, okay, delta U is also equivalent to the work done. So this equation number 6, can be used for the case to find W. Okay, so the test charge that they give in the question is negative 1.5 nanocoulomb. Okay, and the potential difference will be between Vs minus Vt. Okay, so let's do our substitution here. So the negative from 1.5 nano must be included. Okay, and then it's Vs minus Vt, which we have calculated from the previous question. So we will obtain the answer in this case as negative 4.86 times 10 to power of negative 7 joule. Okay, so this question applies the concept of potential difference and also work done. Alright, that's all.